Hey guys, it's Mr. Barth. I'm just going to go through the answers for yesterday's homework. Please check them. There were quite a few problems here, and I think if I walk you through these, it's going to help a bit. Okay, so the first five here are basically all the same. You're just applying the definition of a negative exponent. Okay, and most of you guys got these. Okay, so a to the negative 1, this is the same as 1 over 8 to the first. Or you can just write 1 over 8. Okay? 3 to the negative 2, that's 1 over 3 to the second. Okay? Anybody that wrote 1 over 9, that's fine also, because 3 to the second is 9. Y to the 7th, that's 1, or y to the negative 7th is 1 over y to the 7th. W to the negative 12th, that's 1 over w to the 12th. And x to the negative 1, this is almost the exact definition that I taught you yesterday. And this is 1 over x. And you can write x to the first, but it's really just 1 over x. Okay. Now, I'm going to switch to a different sheet here because some of these have multiple explanations here. All right. So number 6 is 3x to the negative 1. Okay. So by the definition, if you have a to the negative 1, that's the same as 1 over a to the first. Okay, so right away I could just take this entire thing in here and treat it like a, and so this is 1 over 3x to the first. Okay, and I'm done, which is the same as 1 over 3x. Or, another way to look at this is if I use the power of a product rule. Okay, I take each of the factors inside and raise it to whatever the exponent is. So this is the same as, and if I use the power of a product rule, this is 3 to the negative first times x to the negative first. It's sort of that rule where you distribute the exponent to the two factors inside. Now again, that only works if they're just factors in here. If you put any addition signs in here, then the rule doesn't apply. Now, this thing right here, if you take each of these individual elements here, 3 to the negative 1, well, that's 1 over 3 to the first. And x to the negative 1, that's 1 over x to the first. And if I multiply this straight across, I get 1 over 3x, which is the same either way. Okay, let's take a look at number 7. Okay, and a few mistakes here. All right, I just want to keep this in mind. This is number 7, and that was 4c to the negative third. Now, I want to be very clear. If you see an expression like this, the negative 3 is affecting the c only. Okay, this is not 4c to the negative 30 power. This is 4 times c to the negative third power. And if you need to break those apart to make it more clear to yourself, that's fine. Do so. Now, if I wanted to raise this whole thing to the negative third power, I would have written 4c to the negative third power. That's not what the writer of this problem intended. Okay, so we're not going to write that there. Okay, now the idea is that this c is raised to the negative third power. Well, that means this, 4 times 1 over c to the third power. Now, if you would write this, the true simplified version is I'd write 4 over 1, and then I would multiply across, and I would get 4 over c to the third. That's your answer. Okay. A few of you guys had some different versions, looking something like this. But this would be your correct simplified answer. All right. 8. Same, almost identical problem. I shouldn't say identical, but the same issues came up. If I have 2pr to the negative fifth power, okay, the only thing being raised to the negative fifth power is the r. Okay, so you can write this out as 2 times p times r to the negative fifth, and you want to write 1 over r to the fifth by the definition that we learned. Okay, now keep in mind, any of these, either constants or variables, can be written over 1. So when I multiply this all across, I do 2 times p times 1, that's 2p. And 1 times 1 times r to the 5th, that's r to the 5th. And there's your simplified version. Okay, let me go to a new sheet here. All right, number 9. Now, this is the one that can be truly useful as these get more complicated. So 9, all right, and kind of, well, let's see if I can explain it this way. All right, this is 3/4 raised to the negative 1 power. Well, that means that I need to put this thing over 1 and raise it to the first power. So it's 1 over 3/4 to the first power. But what does this say, really? This is 1 divided by 3/4. Well, 1 divided by 3/4, that's 1 times 4/3, which is, of course, 4/3. That is your simplified answer here. Now, if you're looking at this and going, wait a second, is there a shortcut here? And the shortcut is yes. When you raise something to the negative 1 power, it's basically, it's reciprocal raised to the first power. And I could put a 1 out here if I really wanted to. And that sort of makes sense going back to the actual definition. If, what we originally said is a to the negative 1 power equals 1 over a to the 1 power. Well, this thing is the reciprocal of this. I mean, think of it like this. This is a over 1 raised to the negative 1 power. It becomes, basically it looks like this. A over 1 to the negative 1 power equals 1 over a to the first power. Okay? So the effect of the negative 1 basically turns it into its reciprocal. Now, wasn't expecting you to make that leap by yourself, but that is the case, and apply it where you can. And you may definitely use it on tonight's homework. All right, so I got 10. This is number 10. This is x to the negative 2 times x to the negative 2. Well, if you're going to use the product of powers rule, okay, this thing is going to equal x to the negative 4th power, which simplified using the definition of negative exponents rule, this is going to be 1 over x to the 4th. Okay, now, different way to do this is if you want to change each of these, this is 1 over x squared times 1 over x squared, and if you multiply that straight across, you're going to get the same thing. Okay, so sometimes you have options with these because they're all multiplication, basically. Okay, sometimes the exact order of operation gets a little confusing, but it's because they're all all multiplication. All right, 11. Now I'll switch to a new sheet here. All right, 11. I have, the original problem is y squared to the negative 3rd power. Now again, this is one of those ones that you can do 2 ways. Now, the easiest way is to do the power of power rules and say, hey, this is y this to the 2 times negative 3. If you remember this rule, when you get a power raised to a power, you have to multiply the 2 exponents. This is negative 6, okay? And that becomes 1 over y to the 6th, and you're done. Okay? Now, an alternate way you could do it, and I don't suggest it in this case, but I'm just trying to give you options here. So, this is the same thing as 1 over y to the 2nd raised to the 3rd power. Okay, it's sort of pretending that this is a from that original definition. Okay, and then once you do that, that of course is 2 to the 3rd. This is 1 over y to the 6th because you just multiply those two. And it's the same thing. Okay, and you may find multiple ways to do these. Number 12, last one. Hopefully this was one of the easier ones for you. This is 5 to the negative 2 times 5 to the 2nd. Now, if you write this out, if you use the negative exponent definition, this is going to be 1 over 5 to the 2nd times 5 to the 2nd over 1. Okay, and then when you multiply straight across, some of you guys are going to notice this is 5 to the 2nd over 5 to the 2nd, which of course has to be 1. Now, others of you may have used the product of powers rule, and when you multiply them, that means you add their exponents. This is the first rule I taught you. Okay, last Wednesday, or I don't know what it was, Thursday. And if you add their exponents, this becomes 5 to the 0 power, which is our definition of a 0 exponent rule. Okay, and that is 5 to the 0. It would be 1 also. So either way you want to look at it. Okay, hopefully that cleared some up because we did have some mistakes there.